So when I start off, remember we talked about we can look at functions from an equation, a graph, a table. It can be represented as a set of ordered pairs. So we're looking at a table because sometimes you're not going to be given a graph. Sometimes you're only going to be given a table, and you're still going to have to be able to determine key features from the table. And you also need to be able to evaluate from a table. So the first thing that we're going to look at is evaluating f of -1. So this means the same thing as, remember, let x equal -1. What does y equal? That's what it's saying. When x equals -1, what does y equal? So I'm going to go to -1 on my x side, my x column. And when x is -1, what is y? 7. So f of -1 is 7. What about f of 4? Well, this is just saying, hey, let x equal 4. Tell me what y is. So when I scroll a little bit so we can see it, yeah, when x is 4, y is 12. We could even write both of those as ordered pairs, correct? This would be the ordered pair, -1, comma 7. And this would be the ordered pair, what? Owen? Positive 4, comma 12. I love that. Perfect. Okay. So question B says determine the value of f of 3 minus f of -3. So I have to find out what's happening when x equals 3, and I have to find out what's happening when x equals -3. And I need to find the y values for those. That's what I'm doing. So when x is positive 3, y is 15. When x is -3, y is -9. But I'm subtracting these. F of 3, this is f of 3, minus f of -3. So I have to subtract these two. So what happens when you have minus a negative? What do we do with that? Yeah, you turn it into a great big positive. So 15 plus 9 is 24. So f of 3 minus f of -3 equals 24. If this function were created, like meaning if it was graphed, if we graphed this function, what would be its y-intercept? And that explain means how do you know? What do we know about the y-intercept? Look at your journal from yesterday. You know something specific about the y-intercept. Everybody needs to pick their head up. Daniel, that means you, or we're going to be, I need you to be awake. Look at your journal from yesterday. What do we know about the y-intercept? Pull out your journal from yesterday. Get it out. Get it out. That's important. Get out your journal from yesterday. What do we know about the y-intercept? Specific. We said something very specific about it. We know that's where it crosses the y-axis, but we don't have a picture. So we learned something else. Get out your journals from yesterday. It's important.
X equals 0.
X equals 0. Tim, awesome. X equals 0. So where in that table does x equal 0? No, at 0, x equals 0. X equals 0 at the point 0, 12. So the y-intercept is 12. Why? Because the graph crosses the y-axis when x equals 0. That is why. That is so important. That is so important. So you're able to identify the y-intercept without a graph. You just look for the place where x is 0, okay? Really important. Question D says, what are the zeros? We learned something very special about the zeros yesterday. What did we say about the zeros of a function? I know that they're the x-intercepts, but we said something special about them. Look at your journal from yesterday. Look at your journal from yesterday. We said something about the zeros. What do you got, Owen?
There where the graph crosses the x-axis.
Okay, but I don't have a picture to look at. What else did we say about it? It's in a parenthesis.
There the x-intercepts.
We said something else about it. It's right after the definition. It's in a parenthesis. What does it say?
Y equals 0.
Absolutely. So we're looking for when y equals 0. When y equals 0, the graph crosses the x-axis. So what are the places where y equals 0? Well, y equals 0 when x is -2. And y equals 0 when x is 6. So my x-intercepts are x equals -2 and x equals +6. And we could write those as ordered pairs, -2, 0, and 6, 0. So that's really like focused on definitions, right? I don't know why that does that all the time. That is definitions. Go away. Okay, let's turn our page. Turn our page to the, trying to get rid of that. Okay. So let's go to example number 2. So for example number 2, you have 3 tables. You have 3 tables. So it says, which of these functions has the greatest y-intercept? So Owen just told us that the y-intercept happens when x equals 0. That's my y-intercept. That's important. So the y-intercept for f of x, well, f of 0 equals 4. The y-intercept for g of x, well, that means I let x equal 0. So g of 0 is 14. And the y-intercept for h of x, so h of 0 is 11. Which one of those is greater? Which one has a larger number? F of x, g of x, or h of x? G of x. G of x has a greater y-intercept because g of 0 equals 14, while f of 0 equals 4 and h of 0 equals 11. Why am I writing all this information? What's the purpose of me like explaining it in this step? What do we use our journals for? Yeah, to help you when you're doing your homework, but especially if you're taking a quiz or a test. So if I just had written f of 0, g of 0, h of 0, and then just wrote g of x is greater. Like I want to explain to you, remember that the y-intercept happens when x is 0. And I want you to see it as a function. I want you to see it as h of 0, g of 0. Know what you're looking for, okay? Are we all good with this? Okay. Okay. Anybody else need this up here? I got you, Alessandro. Good? Perfect. Okay. So Cameron is driving their car home from college. So when Cameron starts, like he starts at college and he's traveling home. That's where he's going. Okay? The distance they are from home is given as a function of time that they've been driving. T is my time in hours. D of T is my distance in miles. So we have to calculate d of 4. So d of 4, what is that? Well, when I let x equal 4, d of 4 is 123. We also have to figure out what d of 2 is. Well, d of 2 is 235. I have to subtract these. I have to take d of 4 minus d of 2. Well, d of 4 is 123 minus d of 2, which is 235. What do you get? What is 123 minus 235? You all have calculators. Pick them up. Let's go. What is it? What is it?
Negative 100.
It's negative 112. It's negative 112. That's important. So it says, give an interpretation about what this result means. So that means, how many hours have passed? Well, from 2 hours to 4 hours. Did it say Cameron? I think that was the name. Cameron traveled 112 miles. Why is it negative? It's negative because Cameron is 112 miles closer to his destination. Yes, ma'am. This one right here. Sorry. We're taking away from the total distance. That's why it's negative. So he's just 112 miles closer. That's why it appears to be negative. So you have to think about what's happening. He's getting closer to home. He's taking 112 miles away from his total trip. Okay, I'm going to leave that there for a second. Raise your hand if you need more time on that. All right, let's look at example number 4. Example number 4. So for the function for the function f of x equals negative 2x plus 8, do the following. We have to use our calculator's table option to fill out the table, to fill out the outputs. So I'm going to write down the calculator buttons, okay? I'm writing down the calculator buttons. So everybody find the y equals button on your calculator. It's gray. It's a gray button. So you are grabbing your calculator and you are doing this with me. You are not just sitting there. Pick up your calculator and find the y equals button. It is gray. Does everybody see it? Okay. Once you press that y equals button, I would hit clear just to make sure that there are no equations in that. So the next thing that we're going to do is we're going to type in this equation. So we're going to type in negative 2x plus 8. We're typing in that equation. Remember that x is right here. X is this button right here. It's right above the pink button on your calculator. It's right above the pink button on your calculator. Use the negative, not the minus. Use the negative, not the minus. Y equals negative 2x plus 8. Okay? Once you do that, you are going to press the second button. It's blue. And then you're going to press the graph button. It's gray. This button is gray, and this button is blue. Okay, I'm coming around to look at your tables. Coming around to check. Perfect. You can scroll up and down in your table. You can scroll up and down in your table to fill out your X and Y chart. So go ahead and start filling those out.
So you go all the way up to -2?
So you have to hit second and then graph. Yeah, go scroll all the way to -2. Let's put this in. Do Y equals -2x plus 8, and then hit second that graph and put your equation. Okay? Y equals, so here, -2x plus 8, and then hit second graph. Okay. Got it, girls? Yep, okay. Y equals -2 x plus 8. Ocho. Second graph. Okay, Michelle, did you get it? Y equals -2x, where's your x, plus 8. Second graph. Okay, so when x is -2, I think that's where we're starting. When x is -2, what's our output? 12. When x is -1. When x is 0. When x is 1. When x is 2. When x is 3. When x is 4. And when x is 5. Yay, I love it when you guys participate. That's totally made my day. Okay, so it says, what is the y-intercept? How do you know it's 5? Oh, what is the y-intercept? Isaac, the y-intercept happens, we find the y-intercept when x equals what? Yeah, so where in the table does x equal 0? Does x equal 0? Where in the table does x equal 0? So the y-intercept is the order pair 0, 8, or you could write it as y equals 8. Okay. What are the zeros of the function? Remember, the zeros happen, I'm just going to write it like this. The zeros happen when y equals 0. So where is this graph crossing the x-axis? Well, y equals 0 when x is 4. Y equals 0 when x is 4. So we could write it as the order pair 4, 0. These are just the definitions that we learned yesterday. Zeros, y-intercepts, turning points. Yes, ma'am. Y equals is the gray button. Those were your calculator buttons. Yeah. Gray, blue, gray. Thanks, girl. Keep her straight over there. You let me know if we're ready to move on. Who needs more time? Okay, thank you, ma'am. Okay, we have one more table, so we're going to go back to our y equals button. So press y equals on your calculator. y equals, and you're gonna type in this equation. Type in this equation. So remember, this is your x button. You have to start with x. So x, and then the caret button. X and the caret button. So hang on. So you're gonna go to y equals, right? Y equals. And then you're gonna type in x caret 2, and then arrow over to the right. And caret button is right here. It's right below clear. Right below the clear. It looks like a little triangle without a bottom. You can, but I want everyone to know how to use the caret because we don't just deal with
Well, I have
squares.
to use the carrots.
This says quit and go to.
Okay, well that's because you did something crazy. So quit and go to. So y equals, we're using the y equals button. We're typing in x caret 2, and then we're gonna arrow over to get it out of the upper portion, right? Get it out of the top. And then we have to type in minus 10 x plus 16. This is our equation. And then we have to hit the second button again. And we have to hit graph. So raise your hand if you can't, if you're struggling. I will help you.
That was not okay.
Arrow over. Okay? Yes, it's minus 10. You see it right there? It's a minus 10x. Okay, so then you have to hit second graph to get to your table. Okay, is everybody there? Y equals x, x, caret 2, and then arrow over, minus, plus, minus, minus 10x plus 16. Second graph. Y equals x caret 2 arrow minus 10 x plus 16. Second graph. Here's your table. Y equals x. Where'd it go? Squared 2. Then you have to arrow over once to the right to get out of the top. Okay? Minus 10x plus 16.
Thanks, Wayne.
Second graph. Second, and then graph. Perfect. Okay, so when x is 0, what did you guys get? 16. When x is 1, what did you get? When x is 2, what did you get? When x is 3. When x is 4. When x is 5. When x is 6. When x is 7. When x is 8. When x is 9. And when x is 10. Okay. So the first question says, what are the zeros? Daniel, what are the zeros of the function that appear in the table? And remember, the zeros happen, it's some number when y is 0. That's what it's going to look like. You're looking for any number with a 0 as the y coordinate. So tell me one of your zeros. I want the ordered pairs. Yeah, so 8, 0, that's one of them. Good job. 2, good job. We're looking for when y is 0. So my zeros are x equals 2, and x equals 8. Or we could write it as ordered pairs, 2, 0, and 8, 0. Okay? Remember that the zeros happen. Lysandra, are you with me? Zeros happen when y is 0. Does the function appear to have a turning point? What happens at the turning point? What does it say on yesterday's journal? It changes direction. So we're looking for when it changes direction. How in the heck are we going to see if it's changing direction, if it's in a table? We do know. We do know. Yeah, it'll go from like decreasing to increasing, back to decreasing, or from increasing to decreasing, back to increasing, something like that. We're just looking for one turning point. We only have one turning point, so we're just looking for when it's decreasing and then goes to increasing, or increasing back to decreasing. So remember that when we talk about a function increasing or decreasing, we're talking about the y values. Is y getting bigger or smaller? From 16 to 7. Smaller. 7 to 0. Smaller. 0 to -5. Smaller. -5 is less than 0. -5 to -8. Still smaller. -8 to -9. Still smaller. All of this is getting smaller. Okay? But what happens here? What's -9 to +8 or to -8? It's getting bigger. -8 to -5, bigger. -5 to 0, bigger. Bigger, bigger. So it's getting bigger right here. Where did that change happen? The change happened at the turning point 5, -9. This is my turning point. This is my turning point. Do you guys notice that this graph, like once you get to -9, if you move to the right or to the left, those outputs repeat? -8, -8, -5, -5, 0, 0, 7. Did you guys see that? It's because it's symmetrical. So what is our turning point? Our turning point is the ordered pair 9, sorry, not 9, 5, -9. Our turning point is the ordered pair 5, -9. Michelle, you need to get up.